Thank you very much. I want to thank the Therapeutics Initiative Committee for the invitation. My name is Eitan Agai, and I'm the founder of PicoPortal. And what we will discuss today is addressing challenges for applying systematic review methods using AI. I'll start by a quick introduction about my background, which is relevant to our discussion. Then we will move into the state of PicoPortal, and immediately we'll dive into AI under the hood, and we will conclude with Q&A. So I started my career as a structural engineer. Here you can see me having lunch on one of the largest suspension bridges in New York City. One of the interesting projects that I worked on was the restoration of the Statue of Liberty. And clearly you can see the difference between the flame that it's on the left versus the gold plated flame on the right. And later on, I became a partner within an engineering firm which built the largest suspension bridge in the world called the Verrazano Narrows Bridge. In the 90s, I started my own company and immediately became involved with the mortgage banker industry. And later on, was lecturing around the country on using automation and primarily AI technology within the mortgage industry. During the pandemic in 2020, I was scratching my head sitting in my apartment in New York and figuring out like how can I help researchers do better research. And then I realized that the same pain point that researchers are facing are similar to underwriters in the mortgage industry, which has to do with a lot of data, the quality of the data, identifying eligibility, etc. And the result of that is that PicoPortal was born. The first release of PicoPortal was in September 2020. Since then, it gained quite a bit of popularity. As you can see, there are users from over 70 countries that are using the platform. There's about over 2 million citations that are being uploaded into PicoPortal. And just in the US, users represent over 200 different industries, such as hospitals, universities, government agencies, and the private sector. So that we're all on the same page, so to speak, I want to start by saying that everyone is looking for evidence, whether you're a clinician or you are a policymaker or you're a patient or you're an insurance company. Everyone is looking for evidence, and the gold standard for evidence is the evidence-based medicine, which is within that we can see a whole hierarchy, which the top of the hierarchy is systematic review or evidence synthesis, and that's what we're going to discuss today. So what is the process of systematic review? Basically, researchers are doing their search on different biomedical databases such as Embase, World of Science, Google Scholar, PubMed, Cochrane, etc. And then they get many articles once they finish their search. Many times it's in the hundreds, even more often it's in the thousands. Within that, they need to cast a net and select the few, typically anywhere between 1% and 10% of the articles that are relevant to their particular study. Tools such as PicoPortal help researchers do a better research by first, from the point that they ask a question until they will collect data for evidence synthesis. So it's all start by setting up the project. For example, the team leader need to develop a search strategy, a protocol, invite team members to help him, decide what type of workflow they're looking for, meaning is each article would be reviewed by one reviewer or each article need to be reviewed by two reviewers with adjudicator. And then once the project is being set up, the team is moving into deciding on the eligibility by first screening the abstracts and then moving into a full text review. And from that, they assessing the quality of the studies as well as extracting information. So they perform risk of bias and data extraction. And once the information is being collected, they move on with the workflow to do some evidence synthesis and finalize their research. To my surprise, many researchers are still using tools such as Excel spreadsheet, which obviously is not the most efficient way to screen 1,000 or 4,000 or 5,000 different articles, let alone find duplicates and some other challenges that are being faced when you manage an entire team. Result, extended timeline, both for abstract screening, full text review, data extraction, risk of bias, and so forth. So tools such as Pico Portal, which is quite sophisticated and is powered by an AI engine as well, can help shorten the project timeline. Now, I know when I heard that many people are asking, is AI is going to take our job? And I think my take on that is that no, it will not. But for those that are not using AI, they probably will not be able to be competitive, and those are the jobs that disappear. So it's to our advantage to look at tools that can help us and shorten the timeline, increase the quality of our research. So what is a tool such as Pico Portal can do? So first of all is it helps in abstract screening, both in terms of managing the team, deciding what the workflow is, and presenting the abstract in the way that it's reducing the decision fatigue on the user, especially if you need to review 5,000 articles or 4,000 articles. That's quite a large number of articles. Then with full text, it typically not only help retrieve the full text when possible, but also present the full text in such a way that it's easy for the user to read it. There is also tools within Pico Portal, for example, that can help you with the data extraction and evidence mapping, the risk of bias. There's a flexible workflow for scoping review, systematic review. Like Pico Portal is an example, is not an opinionated system, so you can choose your own workflow. And there is a crowd engine that help you manage. However, our discussion today is more about what AI is, what it all means. And for the purpose of evidence synthesis or for systematic review, we will focus primarily on machine learning and deep learning. So if we talk about machine learning, there are definitely different type of tools that perform machine learning, and it's basically creating a decision. It's a decision algorithm to make prediction based on observing patterns. So what we mean by that, it's primarily similar, let's say, to your cell phone, that as you start typing, for example, if you type the word happy, the cell phone will suggest to you that it's a birthday. And the reason is because the phone already observed your pattern and realized that every time that you type the word happy, it usually follow with the word birthday, and as a result, it's suggesting that. This is a very similar to the way that machine learning work within systematic review or evidence synthesis. And there are different algorithms such as decision tree, which is a classification tool. For those that are familiar, like SVM is one good example for that. There is a clustering technology, so that's a little bit different. So clustering is more like examining the data set and breaking it down to similar groups. So here is the word cluster come from. And deep learning, which help primarily in natural language processing, which is identifying relevant keywords and phrases within the text itself. So how it's being used? Well, with machine learning, there are basically two type of classification. One, what we call like more of a passive classification. So we know ahead of time what the criteria are, and we train the machine to meet those criteria. In active learning, which is more typical to systematic review, we don't know ahead of time what are the eligibility criteria. So the machine needs to basically learn as the user is screening those articles. So for example, on a typical classical classification, so to speak, um, if let's say we want to train the machine to distinguish between chihuahuas, as you can see on the picture here, and muffins, as you can see over here, we basically will present the machine with 100 pictures of chihuahuas, for example, and 100 pictures of muffins. And then the machine will be able to classify what's considered as a chihuahua, what's considered as a muffin. However, if we will present another picture of a dog that it's not a chihuahua, in this case, the system does not know exactly what this dog is, but it will still classify it as a chihuahua and not a muffin, but with a low confidence level. Let's say 70% confidence, and we'll say I'm 70% confidence that it's a chihuahua, but it definitely is not going to classify it as muffin, more likely, I would say. Now, deep learning works a little bit different. Deep learning works more on a contextual information. By that, we mean that it really reads the information, let's say abstract or full text, more like the way that a human does. So if we take the word right, as you can see over here, you can see that those two right has quite a big difference between them. One, that it's related more to rights inherent to all human beings, versus the second right is the right angle in an internal angle, which equal to 90 degrees. So those are two different words, and the deep learning has the ability to understand that the first right and the second right are not the same. It's the same thing like if you would say a river bank versus I deposit money in a bank. Those are similar things. Now, machine learning within systematic review is being used on many aspects, like starting with duplication on clustering. So clustering can be used, for example, to identify articles that look the same and breaking down to smaller groups. Or classification, which is, for example, if you have a body of articles that are considered as RCT or random control trial versus non-RCT, non-random control trial, you can train the machine to classify which article is RCT and which one is not ahead of time because we have a body of information and this is a very clear distinction. Moving into prediction, this is a little bit more challenging, as I stated before, because we don't know ahead of time what is the eligibility criteria. And the machine needs to observe what the user is looking for, and based on the selection criteria, start predicting what are the relevant articles. Then we can move into risk of bias and data extraction and even summarizing tests. But one of the things that you can see from this chart is that the algorithm becomes more and more complex, obviously from a simple one of clustering, which been around for many, many, many years, like something like k-means, for example. into deep machine learning like BioBird, those becomes very sophisticated algorithm challenges for individuals such as myself that develop tools is to keep the user experience more or less flat, that no matter how complicated the algorithm is, from a user perspective, the experience is fairly intuitive and straightforward. So if we will dive a little bit deeper into synthesis or systematic review, as we talked about, the the algorithm is an algorithm that has to deal with determining eligibility. Which article that we have in our data set is going to be eligible for my study, and which article is going to be excluded because it's not. So let's say that we upload um, an entire data set from PubMed, for example. And if we look at the project time, you can see that the red dot, which means articles that should be excluded, versus the green dot, which is are eligible articles or articles that should be included, they're scattered in a fairly random way. And my team needs to screen the entire data set. So let's say that this represents 5,000 articles. You need to screen the entire data set in order for you to find the eligible articles. Obviously, this is very time consuming, and the question is there is a better way of this? So the answer is yes. And by using machine learning or AI technology in this case, um, once the machine learns from the user what are the eligibility criteria, it can push the eligible articles to the beginning of the timeline, as you can see over here. So you see more green dots or articles that should be included versus red dots, which is articles that should be excluded. And toward the end of the project, you can see that there's more excluded articles than included articles. Somewhere there is a golden bar, and this golden bar is a demarcation point where the user can make a decision how to move forward, because most of the articles from this point on will be articles that should be excluded from my. If we will take into example on a real project from the National Academy of Sciences, what you can see at the beginning, if the x-axis represent the timeline, what you can see at the beginning that the machine was learning, kind of watching what the user is doing and what are the eligibility criteria. So here again, all the green dots are um, articles that the user included their studies, and all the red dots are articles that the user exclude from their study. And the machine is kind of learning the pattern. Once it did, it kicks in and it re-ranked those articles in an order that most of the articles that were eligible and should be included in my study are being pushed to the beginning of the project. So now what the user will see is primarily eligible articles. And then toward the end of the timeline, the remaining articles are articles that are overwhelmingly should be excluded. Here and there we see a green dot, but most of those articles should be excluded. And somewhere here there is this demarcation point, or the golden bar, as I like to call it, where the user can make a decision of how to better utilize their resources. So for example, in a traditional systematic review, the project lead upload the data set, and then once the data set is being uploaded and the team is being selected and the team start the review, each team members get a batch of articles. They review those articles for eligibility. And then once they finish and it meets the eligibility back, and it's being recorded. However, if we look at active learning, which is learning while the user is deciding about what those articles are, um, what the Pico portal in this case does is actually pushing it into an AI engine that analyze the eligibility criteria and re-rank the remaining articles in such a way that the most eligible articles will be pushed to the beginning. So it update the data set, and now when a user is getting a new batch, they will get a batch based on this re-ranking over here, where the articles that they will see are the articles that are the machine determined that it's the most likely include. And this process is iterative, so it goes on and on until such point where the machine says, you know what, I know enough and I don't need more data to learn, and I'm quite sure that my prediction is correct. Now, at the same time, the system needs to provide some sort of an analytics so that the project lead will be able to determine where the machine is in the process and determine, did we reach a golden bar? Did we reach a point where I'm satisfied enough where I can make decision on my resources, for example? Should I continue with the abstract review, but reduce it from 2 people to 1 person and move the rest of the team into a full text review, and by that, shortening the timeline? Or if I'm doing scoping review, perhaps I have enough evidence that I can stop altogether and start my full text. Now, within Pico Portal, as I mentioned, we are using active learning to learn as we go. We use engines that are, part of them is deep learning and other part is decision tree. So it's 2 different engines. And And we have a voting algorithm that actually decides which one performed better on my data set. Is it the deep learning or the decision tree? And based on that, we rank the articles based on the winning algorithm. We also provide AI analytics, as I said, to make to inform the project lead where the AI is, so that they can decide how to move forward. We also have a simulation engine. So if you have an existing project and you would like to see how well the machine would have done using prediction, we can simulate that. And of course, there is average. Now, one of the things that we've seen is that the prediction, for sure, increase the screening efficiency. We call it AI assist because we don't really make, or Pico Portal does not make decisions for the user. They're just assisting them for how to move forward. But in this case, if we look at the bottom on the x-axis, those are the percent of articles or records that being screened. So 20% over here really represent that 20% of the entire data set was already screened and 80% was not screened yet. On the y-axis, we have the proportion of title and abstracts that were included and captured so far. So for example, if we look at 20%, we can see that for this orange line over here, the system at 20% already captured 65% of the eligible abstract, but depends on the study type, you know, whether it's an infectious disease, a socioeconomic disparities, environmental lifestyle, diagnostic assessment, it can go anywhere between 65 and 95% in the data sets that we tested. The black line over here, which is like 0.5 basically, this represents a random screening, meaning if AI is not being used, at 20%, you will find on average 20% of your eligible articles, and at 70%, you will find on average 70% of your eligible articles. But using machine learning, let's say at 60%, as you can see, the range is that you can find already anywhere between 95 and 100% of your eligible articles, and you can save yourself the remaining 40% from screen. If we look at specific projects, like for example, the guidance on PFAS, we can see that the user uploaded about 5,060 articles and 627 abstracts were considered as that should be included in the study. And after full text, only 162 will remain. Now, if we look at how the machine actually performed using the similar example where the x-axis represents how many articles are being screened, we can see that at the 20% mark, if we look at the blue line, about 95% of the abstracts were eligible abstracts already being identified. Now, when we look at those abstracts and we compare them to what was the final results on the full text, we can see that the orange line that actually take the same abstract but really apply the inclusion criteria to the full text, we can see that the machine actually is more sensitive, perform even better, and identify at this point 100% of the eventually eligible full text. If we'll look at another example, like in this case, it's a human health risk assessment. We can see that the user uploaded 4,200 articles. Now here, the number of articles that were considered as eligible were very small. It's about, I would say, close to 2% and or even less. So, but really for full text, only 32 were included. Like after screening the eligible abstract, only 32 were included, which really represent about 0.7%. So here again, what we see is, given the number of includes and exclude, you can see here that when the users screened about 28% of the articles, they already identified 100% of the full text at this particular point. Now the user continued to screen, as you can see here, but imagine that after looking at 28%, you already identify 100% of your articles and you don't have to go through the entire, as you can see over here. Now, if I will use a map and we will look at how abstract screening is compared with what was the final eligibility criteria for those full text, you can see that they actually moved up, meaning consistently the machine identified the eligible abstracts better than they were. So we'll go back and when we can zoom in, for example, if I will look at this particular point, you can see here the difference between the human screening and how they continue to screen, probably because they wanted to be on the conservative side. But in reality, they could have stopped somewhere around here because they already identify all the eligible articles, except that they didn't know it. Now, this difference between the two vertical lines that you can see over here is about 40 additional hours that were added to the screening just because the user continued to screen. And this is not even representing 100%. Now, I'm not suggesting that I have all the answers of why and what. It definitely requires an in-depth research. And those of you that are interested in taking such a task on yourself, you're more than welcome to contact me. I'm just saying that by observing what the machine learning is doing, we can see those type of patterns over and over again, that the machine is highly sensitive and really can determine better what are the eligibility criteria compared to review. Now, one way that within machine learning that we determine performance is by looking at something that we call confusion metrics. Some of you might be familiar with it, some of it might not. But basically, we kind of like measure what are the true positive, meaning the machine determined that the article should be included and the human determined that the article should be included versus true negative, which the machine determined that the article should be excluded versus the human that determined the same. We can see in this particular chart, which is scales from 0 to 8,000, that by far and large, the machine predicted the eligible articles, or I'm sorry, the excluded articles fairly well, and it has some false positive. False positive are articles that the machine said they should be included, but at the end, the user determined that they should be excluded. Now, this is not such a big deal because it really means that it adds a little bit more work to the user since the user needs to review those articles, but in essence, those articles should have been excluded altogether. However, to see the eligible articles, since there is such a small part, we had to turn off the false positive and the true negative. And now the scale changed from 1 to 16. And you can see that when the machine says that this article should be included, kind of agree with the human. And there were only 3 or 4 articles, or 0.01%, that the machine had what we called false negative, where the machine said it should be excluded, but in reality, the user did include that. Now, those kind of cases, typically we see them at the early on while the machine is still learning before it gets to a point where it's stable enough and it does a good prediction, but they do it. With PicoPortal, we provide some analytics, and as you can see here, like we can show you what's the percentage of articles that are being reviewed so far. And if you want to capture, let's say, 98% of all the abstracts, how many articles you need to screen. So in this case, you have to screen 2,681 articles to capture 98% of the articles. Now, maybe if you're doing scoping review, 90% is good enough for you, so then that number can be reduced to 24. The number of articles overall is north of 4,000. So this just represents the number of articles that you need to screen to get to 100%, as you can. Let's look on a project timeline. So by using machine learning, you can see here this is a real project. That early on in the project, the machine was learning. So how can we tell that? The red line determined the articles that were excluded. The green line determined the articles that were included. And you can see the ratio between the red line and the green line. So you see that it's somewhat random. But very quickly, once the machine kicks in and it becomes better in doing the prediction, you can see here that it's 50-50, like most of the articles that the user screens, 50% of them were included and 50% were excluded. Later on, the ratio even changed that many more articles were included than excluded. And then toward the end of the project, you can see that the majority of the articles were excluded from the research, and maybe a few articles were considered as included. There are other use cases for AI, even within PicoPortal. So we use natural language processing to highlight relevant keywords. We use decision tree engines such as SVM to determine whether an article is considered as a random control trial or not. We use things such as BioBird to determine eligibility. So there's plenty of technology behind the scene that it's being used. So let's take a look at some. Here what we can see is a body of articles that were uploaded into Pico Portal. And by using a classifier, such as SVM, for example, we can determine whether each one of those articles consider as random control trial or not. So we draw a line, a threshold, and we say everything above the line, meaning articles with high level of confidence that they are RCT will be considered as RCT, and articles that are below the threshold will be considered as non-RCT. The system, or Pico Portal in this case, is not making a decision for the user, but rather informing the user. So if we look at an abstract, we can see that behind the scene there is an AI technology that does a couple of things. One is highlighting the relevant keywords. Two is also presenting to the user, as we saw in the previous case, whether the article is an RCT or not. So you can see here article analytics, and it just tells the user that this article is a non-RCT. It also let the user know that the full text in this case is a foreign language. However, it also highlights keywords, and there are different colors over here. So the yellow represent population, and clearly in the title you can see patient with COVID-19. And even here we use the confidence level to highlight to the user that the system was very confident about the word patient, as you can see, as a much stronger yellow than with the words with COVID-19. But since they're adjacent to each other, it highlights all of them. The purple color represent intervention, and the green color represent outcome. Now, the reason that we do that is primarily to reduce the decision fatigue, since there are many articles, let's say in the north of a few thousands that users have to screen. By just screening the relevant keyword rather than reading the entire abstract, it reduced the amount of time and the decisions that the user has to make. And they can use on the top right, as you can see over here, one of the buttons to decide whether the article should be included by answering yes, or maybe if they're not quite sure, or excluding them using the PICO's criteria or some other criteria. We're also moving into full text highlight and data extraction. So if you look at the PDF image on the right side of the screen, you can see that Pico Portal already highlighted the population in yellow and the outcome in green. This information should help the user during the full text review, as well as it can be pulled out into a spreadsheet to lay out the foundation for data extraction. Other technologies that are moving forward are summarizing text. So it's taking the data extraction or everything that you already collected and moving forward into summarizing them and laying out the foundation for your study. So there are different technologies such as BERT, ChatGPT, and Roberta that are being used to do like that. In this case, if we will look at summarizing text, we can see that there are three studies that I collected here from the spreadsheet. Each row over here represents one study, and each study has the data that was extracted was related to study objective, population, and outcome. Now, one of the things that I did just before preparing for this webinar was to find an engine that will summarize for us, for example, those three studies that represent the study objective part of it. And I copied and pasted, and it generated the text here on the top right, where it shows the study objective, and it says the aim of this study was to evaluate thinning of membrane, etc. Now, we can see that this is not accurate. I mean, there are three studies over here. Here's just talking about one study. So obviously there is more work to do. Or in the case of population, again, it's just referring to the result of the study in terms of the results of all the studies. It's referencing the Journal of American College of Surgeons, which I'm not quite sure where it came from, but it gives us some sort of an idea that as time goes by, and maybe within a year or so, we'll be able to take our data extraction and at least get a basis, some foundation for our paper, where it will make it much easier for us or more straightforward to move forward with putting the final version of the paper, since it will lay out for us the various technologies. So it's not ready yet, but it gives us some sort of an idea of where this technology is heading. So let's conclude our journey with how AI and the challenges of AI within systematic review. I hope you find it useful, and if you would like to contact us, please contact support@picoportal.org, and we'll be happy to answer your questions. Thank you very much.